We are now going to talk about anomalous behavior of lithium. Anomalous behavior of lithium. See, in most of its properties, lithium differs from rest of the alkali metals. The differences arise because of these reasons. Number one is very small size of lithium. Very high polarizing power of Li plus. These are the two reasons which are responsible for the anomaly. We said lithium differs from rest of the alkali metals in most of its properties, and those differences, the anomalies, arise due to very small size of lithium and very high polarizing power of Li plus. Now, the important anomalies, I'll put it in order one by one. Lithium is very hard. This is relatively speaking very hard compared to other alkali metals. Hardest metal among alkali metals is lithium. This hardness is because of great strength of metallic bond, which in turn is due to small size of lithium. We have already said that the strength of metallic bond depends upon the size of the atom. Lithium, being the smallest among alkali metals, has the strongest metallic bond, and that makes lithium hardest among all other alkali metals. Number two, we are discussing differences between lithium and rest of the alkali metals. Number one, lithium is very hard compared to other alkali metals, and we say that it arises due to small size, which makes the metallic bond strong. The next is LiO2 does not exist. We already said in the previous section that lithium does not form superoxide. LiO2 does not exist. Lithium does not form superoxide, and we say that it is because of very small size of Li plus. Being of very small size, Li plus cannot stabilize a large superoxide ion. Number three, we have just now discussed LiHCO3 does not exist as solid. We said there are only 4 solid metal bicarbonates, that is sodium bicarbonate, potassium, rubidium and cesium bicarbonate. All other metal bicarbonates can exist only in solution. Lithium bicarbonate also exists only in aqueous solution, does not exist as a solid. Li2CO3 decomposes on heating. We said all alkali metal carbonates are thermally stable, they do not decompose on heating. Lithium carbonate is the only alkali metal carbonate which decomposes on heating. Other alkali metal carbonates are thermally stable. Look at the manner in which it decomposes. Li2CO3, when it is heated, it becomes Li2O and carbon dioxide gas is produced. So this is how lithium carbonate decomposes. But if you heat sodium carbonate, don't expect this to happen. Instead, it will melt. So these are 4 differences we have mentioned here. Look at them once again. Lithium is very hard compared to other alkali metals. Number 2, lithium does not form superoxide. Number 3, lithium bicarbonate does not exist as a solid. Number 4, lithium carbonate decomposes on heating. Look at the other points of differences. I'll continue here. Number 5, lithium nitrate decomposes to give NO2. This can be taken as a point of difference because all other alkali metal nitrates on heating decompose to give only oxygen gas, whereas lithium nitrate is the only alkali metal nitrate which gives NO2 along with oxygen gas. The next point of difference is regarding lithium oxide and lithium hydroxide. These are weak bases. These are weak bases, while all other alkali metal oxides and hydroxides are very strong bases. Number 7. Lithium combines directly with nitrogen. You know very well, lithium directly can combine with nitrogen. We have seen under reactions of alkali metals with air, lithium is the only alkali metal which can directly combine with nitrogen. The reaction can be shown like this: Li plus N2 gives Li3N. Let us take it as 6. This is lithium nitride. Lithium is the only alkali metal which can directly combine with nitrogen, and it will form lithium nitride. Let's look at the other points of differences between lithium and other alkali metals. We have just now said lithium sulfate does not form alums. Lithium sulfate does not form alums. It is because of very small size of Li plus, it does not form alums. Number 9, lithium carbonate, lithium fluoride and lithium phosphate are insoluble substances. Most of the alkali metal salts are soluble in water. These 3 salts of lithium are insoluble. I told you most of the alkali metal salts are soluble in water, and these are the exceptions. Exceptions belong to lithium. These salts of lithium are insoluble. Corresponding salts of other alkali metals are all soluble. Number 10, lithium halides are deliquescent. Lithium halides, because of high heat of hydration of Li plus, lithium halides are deliquescent and they exist as hydrates. They exist as hydrated salts. Hydrates. Hydrates matlab lithium halides take water of crystallization. Example, LiCl dot to H2O. Sodium chloride does not take water of crystallization. Potassium chloride, rubidium chloride, these substances, alkali metal halides, do not take water of crystallization. Lithium halides, especially chlorides, bromides and iodides, they take water of crystallization. They are deliquescent. Look at the points once again. Lithium nitrate decomposes to give NO2, while all other alkali metals give oxygen gas only. Lithium oxide and lithium hydroxide are weak bases, others are strong bases. Lithium is the only alkali metal which can directly combine with nitrogen to form lithium nitride. Lithium sulfate does not form alums, while other alkali metal sulfates can form alums. These 3 salts, especially these 3 salts of lithium, are insoluble. And then this is another important point: lithium halides are deliquescent and they exist as hydrates. They take water of crystallization. One more point regarding anomalous behavior of lithium is LiX are predominantly covalent and are soluble in organic solvents. See, ionic compounds do not dissolve in organic solvents. Because lithium halides are predominantly covalent, I am not talking about lithium fluoride, this is chloride, bromide or iodide. These substances are predominantly covalent. Being covalent, they are soluble in organic solvents like ethanol, pyridine, benzene, etc. One last point regarding this. Lithium does not form acetylide. Lithium does not form acetylide. That means Li2C2 does not exist. Alkali metals, when they react with acetylene, they form salts of this type, M2C2, but lithium is the exception. Lithium, because of its small size, does not form lithium acetylide. So these are few exceptional points. These are few anomalies which you see in case of lithium. These are the properties of lithium which are not matching with rest of the alkali metals. That's all regarding anomalous behavior of lithium. Let's move on to diagonal relationship between lithium and magnesium.